Hey everyone, and welcome to Chef Success Office Hours on Tuesday, August 22nd, 2017. Today I'm going to be talking about an example pattern that you might use and a cookbook demonstrating that pattern for when you want to test a service or an application that is slow to start or initialize, when specifically testing with Inspec. So let me go ahead and share my screen. Right, so I've seen this pattern come up in various areas in Slack and with various customers. And the problem is essentially this. When using Inspec to test the state of services or applications, some tests may yield incorrect results because the application or the thing that you're testing is slow to start up. So this most likely will happen when you're either testing with the audit cookbook right after a converge of that node, or when you're testing in test kitchen, right? So you'll run kitchen test or kitchen verify, and you would have just converged the node. And if during the converge you had told a service or application to start up, it may not have completed that startup yet. So when your Inspec tests come along and execute, you may get false negative results indicating that the service, well, actually real results that the service hasn't started yet, and it just hasn't had long enough time to initialize. So I've seen several people attempt to solve this with adding timeouts in Inspec profiles or tests and loops. I would almost call that an anti-pattern, because that makes Inspec less deterministic and slower to execute and really harder to maintain over time, because for every service or thing that you're testing, now you have to have these embedded loops and sleep parameters inside that test. And the design of Inspec is supposed to be lightweight, quick, and it's supposed to execute deterministically and as quickly as possible. So with that in mind, I want to propose an alternative kind of way to tackle that problem. And it's effectively giving the service or application some time to start up before we test with Inspec. So, and we can do this in the recipe. And if the service never actually starts, then we can fail the converge. And that way you know that, well, the service actually isn't starting, so I need to change the way I'm starting the service, or I need to re-architect the application, or what have you. So generally, Ruby blocks are not something that should be overutilized in Chef, but this is a perfect solution for using a Ruby block, because it's very lightweight and it is not actually making any changes to anything on the node. It's just testing it. So what that would look like is in this example cookbook, and it's under my GitHub account, and it's called Test Slow Service. So let's just walk through what would be required. So in this specific example, I'm using Windows, and they're bundled with the Chef client. There's a really nice library called Win32, and it has a sub-library or module named service, and that will allow us to completely to check very rapidly the state of any service. But we need to require those into the namespace, and the way we do that with platform-specific test is simply by adding a library, and you can name it whatever. And testing for the Ruby platform, if it's any of these, that means it's a Windows environment, so you can require these. Now, this guard right here is essential, because if you're going to converge this recipe, if you wanted to make this a platform-independent cookbook, these libraries don't actually get bundled with a Linux or Unix Chef client, only with the Windows. So this prevents you from requiring things that don't exist when not in Windows. So the recipe itself is going to have a service that you're going to start. And this could be something like your own company's application, or in this case, it's just a simple service that exists on Windows that I happen to pick out of a list. And it starts up quite rapidly, but it's just an example. So it's the logic is all afterwards inside of this Ruby block. Since it's a Ruby block, it executes in order of from top to bottom in your recipe. So this will execute after this block or this service. And it's so simple. It's basically just creating a loop, and it's checking for a counter to equal 5 or until state is equal to running, then it will exit that loop. And for each loop, it's going to log a warning and indicate the state of the service. It's going to sleep for a number of seconds. This is where your delay is going to come in while you're waiting for the service to start up. And then we gather the state of the service by calling that library status method and give it that service name. And we ask it for its current state. And then we increment a counter. And this just keeps happening until something changes or the counter equals 5. So if at the end of that the service is still not in a running state, then we're actually going to fail the converge because we have a problematic service and something's not right with the way we're starting it up, or we need to re-architect it, like I mentioned before. And this simple pattern allows us to keep our Inspec tests lightweight and agnostic of any startup times that may exist for random services. So we're just going to check as normal without sleeping or looping, and we'll have a super simple, easy to maintain test or profile if you're running compliance scans. And it's just describing the service and saying what it should be doing. And this wouldn't be a demo if we didn't run it. So let's kitchen converge this cookbook. And you can clone this repo and test this yourself and kind of modify things as you see fit to your own environment. And what we'll see is the service starting up, the Ruby block executing. And since this was a service that starts up very quickly, it only went one time through the loop. So we can actually pretend like it's not in a running state by simply changing the check and reconverging. And this is what it would look like if the service was taking a while to start up. Should only take a few minutes, or seconds rather. All right, so the first time it's unknown. Now it's looping through and sleeping for that determined time period. It'll go through 5 of those, and then it'll exit. So that's it. And it didn't fail because I didn't change the fail parameter. It's actually really in a running state. I just changed the check. So that's it. And I'll stop the recording. Thanks for watching that.